Hi Calculus, welcome back. Our objective today is going to be to do a more fundamental theorem of calculus. We're really just going to rearrange what we did last time. But this pops up so much on the AP exam, I did want to dedicate one lesson to it. I've got the checklist on the screen. You know what to do from here. Alright, so last time we found that in order to compute the area under the curve, we can use what? We can use antiderivatives. Also known as indefinite integrals, right? So go ahead and write that in your notes. So we found if I want to evaluate this definite integral from a to b of f of x dx, in other words, if I want to find the area under the curve, I can find an antiderivative, which we usually denote as capital F, evaluated at b minus capital F evaluated at a. And again, what is capital F? Capital F is an antiderivative for little f. So in other words, the derivative of capital F is little f. Another way to think of this, can you write this, please? Can you write the integral from a to b of f prime of x dx? So if I want to find this definite integral, I first need an antiderivative for f prime, right? Which would be what? Just regular f. So this would be regular f of b minus f of a, right? Because a little f is the antiderivative of f prime, okay? Now what I want to do is, can we go ahead and rearrange so that, can we go ahead and solve for f of b? Is that showing up there? Yes. Okay, so if I want to get f of b by itself, what would we need to do? I need to add f of a, right? So if I want f of b by itself, then that would be equal to f of a plus that integral, right? So plus integral from a to b of f prime of x dx, okay? So all we did was a little bit of rearranging, but we actually use this rearrangement so much. So I'd like for you to write that in your notes, stars, exclamation points, whatever by it, so that it's easy for you to come to. Alright, so why do we care so much about this rearrangement? You don't need to write any of this, I just want to talk it through. So if we have that rain begins to fall at midnight, which we'll call t equals 0, at a rate modeled by r of t, which is measured in inches per hour, then what does the following integral represent? What are the units? Well, we learned from the beginning that this gives me how much accumulation, right? How much rainfall from, I guess that'd be 3 a.m. to 6 a.m., right? And so the units would be the units of r of t times t. So the time would cancel and the units would just be in inches. So this would give me how much rainfall from 3 to 6, correct? Okay, now what if I did this? So let's say that there are 2 inches of rainfall at 3 a.m. What does this represent? Well, we already said this is how much rainfall from 3 to 6, right? And we started with 2, so this would give me my total rainfall, right? How much rain I have at 6 a.m. Well, this is exactly what the rearrangement of FTC is saying. It's saying, okay, this would be, say, capital R of 3 plus the integral from 3 to 6 of little r, which is the rate, and that would be equal to capital R of 6, okay? So in other words, where I end is where I started plus how much accumulation I've had, right? Which is not anything earth-shattering. So this is really what the rearrangement of FTC is saying. My final value, so f of b, is equal to my starting value plus how much I've accumulated, how much rainfall between the two, right? And so that, again, that's all the rearrangement is. And force a pause on the screen if you want to write any of this, feel free, otherwise just hit continue. And force a pause on your screen, can you please copy example 1 for me? Alright, so we have f prime, and we are also given f of 0 and asked to find f of 1, okay? So this is a big light bulb for me. I'm thinking, oh, I need FTC, I'm going to have it rearranged. Here's why. You're given a derivative and 1 point on the original and asked to find another point, okay? So here is what we're going to do. Let's first go ahead and identify A and B. Works best if you let A be your smaller x value, okay? So look at your two x's. You've got 0 and 1, so what do you want A to be? A is going to be 0, B will be 1, right? And so remember, don't write this yet, we know that if I want to evaluate this definite integral, I can take the antiderivative, which would be f, and do f of b minus f of a. Or we can have f of b is equal to f of a plus the integral, right? That's where we got the rearrangement from, okay? So we are going to go ahead and start with this rearrangement. And now let's go ahead and plug in our a, our b, and our f prime. So jump with me from here. So I've got f of, what was b? 1, which is what I'm looking for, so that's good, equals f of, what was a? 0, plus the integral from 0 to 1 of f prime, which is going to be, let's plug that in, 4x cubed plus 3x squared dx. All right, okay, so now let's just kind of keep working with the calculus. So f of 1 is what I'm looking for. What is f of 0? F of 0 was given, and that was 4, so I'm going to plug that in there. And now I have this definite integral. If it's not calculator active, how can I find this definite integral by hand? Take an antiderivative, right, and plug in 0 and 1. So let's do that. So an antiderivative here, let's see, bump the power up is going to be, my new power is 4. Old coefficient 4 divided by 4 is 1. Plus, and then new power is 3. 3 divided by 3 is also 1. All right, and we want to evaluate that at 0 and 1. Which one should I plug in first? We should plug in 1 first. All right, so we've got f of 1 equals 4 plus, okay, now if I plug in 1, I get 1 plus 1, so 2, minus, if I plug in 0, I get 0 plus 0, so that would be 0. So I'm getting 4 plus 2 minus 0, so my final answer is 6. All right, now what if this were calculator active? At what step could I kind of step back and let the calculator do the rest? We could step back at this step right here, right? So I plug in 4 here, and then I just do what command on the 84? Do math 9 on the 84, and what about on Desmos? Type in INT. So if it were calculator active, you could stop from there and let the calculator do the rest. All right, voice applause on your screen. Penny is here to say hello. Go ahead and copy. I just underlined the important parts, so you can just copy those parts. Okay, so we've got a particle that moves along the x-axis, and our velocity is given, which is, we typically think of that as the first derivative, right? And then we're told that the particle's position is 2 when time is 0, and we want to know the position of the particle at time 1. So again, light bulb, I'm thinking FTC because you're given the derivative function, you're given 1 point on the original function, which would be position, and asked to find a different point, okay? So that is your, basically, f of b that you're given. You're trying to find f of a, and then you're given f prime, okay? Her tail. All right. It's not working, Penny. Okay. So let's write what we have. So instead of like our function f, our original function is going to be our position. Okay, so I'm just going to make a note that f, I'm going to denote it as x. That's usually what we use for position along the x-axis. Okay, so we're given v of t. It says the particle's position when time is 0 is 2. Okay, and we want to know the position at time 1. You love me at the most inconvenient times. Okay. All right, so let's identify A and B. Remember, those are your x values or y values? Those are your x values. So what would you like for A? Yeah, let's let A be 0 and B be 1, okay? So now our rearrangement is going to look like this. So it's going to be, instead of F, we'll have our position at time 1 is going to equal our position at time 0 plus the integral from 0 to 1 of the derivative of position, which is velocity, right? So that is just plugging in our rearrangement here. See if it'll pop up. We're using that, but instead of F, we're using position, okay? All right, so now let's plug in what we know. Again, x of 1 is what I'm looking for. X of 0 is what? X of 0 is 2, okay? Then plus the integral from 0 to 1 of v of t, so that was 3t squared plus 6t dt, right? Now let's say this is calculator active. We are pretty much done, right? Let's go ahead and plug it into the calculator. All right, so we've got 2 plus, and I need this integral. How do I get that again? Math 9. And now I just fill it in. Notice that I'm using x's instead of t's just because those are the easiest to grab here with this independent variable button, and then we'll hit enter, and I am getting 6 as our final answer. So this is all equal to 6. Now if this question were not calculator active, how would I keep going by hand? I need to find an antiderivative here, right? And then plug in 1 and 0 and simplify from there. All right, force a pause on your screen. Can you just copy this graph for me and move it up, hopefully? That doesn't block there. All right, so for example 3, it says that the graph below is the graph of little f, which consists of 3 line segments and a semicircle. Let capital F prime equal little f. In other words, capital F is what? Is an antiderivative, right? So find capital F of 4 if capital F of 0 equals 7. Okay, so let's set this up. I would have, what is my A value? So A is 0, and what is your B value? B is 4. So I would have capital F of 4. Notice we're using capital F instead of little f here. So capital F of 4 equals capital F of 0 plus the integral from 0 to 4, and now I need the derivative of capital F, which is little f, right? Okay, and what do we know about little f? Well, we know little f's graph. That is the graph of little f, okay? So capital F of 4 is what I'm looking for. Capital F of 0 is given, that was 7. And now I need to figure out this integral. Remember, we can find definite integrals in 2 ways. We can find the area under the curve, or we can use antiderivatives. Well, I don't know the antiderivative of little f, but I do know its graph. So I can go find the area from 0 to 4 of this graph, okay? All right, so let's go ahead and look at the area that we are trying to find here. So let's shade first the area from 0 to 4. So that would be this piece, right? And this triangle. Make sure that you are shading the area made with the function and the x-axis, okay? So notice that that first piece I'm going to end up subtracting because it's under the x-axis, right? And then the second piece I will add. Okay, so let's look at areas here. First of all, it said that this whole thing was a semicircle, right? What is the radius of the semicircle? The radius is 2, right? And the area of a circle, let me do C for circle, is pi r squared, right? So the whole circle has an area of pi times 2 squared. So the whole circle has an area of 4 pi. So this quarter circle would have an area of just pi. Do you agree with that? That's just 1/4 of a circle. Okay, now this second piece, the area of a triangle, I'm going to put T for triangle, 1/2 base times height. The base here is 2, and it looks like the height is also 2. So 1/2 times 2 times 2 should be 2 there, right? So that whole integral is going to be, let's do this, 2, and then I need to minus the pi, right? So final answer, 7 plus 2 minus pi is going to be 9 minus pi. Alrighty? So I'm just going to want to leave you with this final thought. These questions are not difficult, especially because they often appear on the calculator active section. So once you've got it set up, you just Math 9, you know? The challenging part is realizing that you need FTC rearranged, especially once you're in the middle of 45 different multiple choice questions, right? So as you're working this assignment, I really want you to think about why you need FTC for each one. So really think about, okay, I'm given F prime, okay, and one value for F. So this means I need FTC rearranged, all right? Okay, go ahead and end with a summarizing sentence or something you want to be mindful of as you start the homework assignment, and I will see you all next time.